Hi students, this is Penila. So in the second lecture of signals and systems, you are going to see mathematical operations on signals. So basic mathematical operations that can be performed on signals are time shifting, time reversal, time scaling, amplitude scaling, signal multiplier and signal addition. So in this lecture, we are going to see time shifting both in DT as well as CT signals. So time shifting performed on dt signal is represented by y of n is equal to x of n minus k. So the signal y of n can be obtained from x of n by shifting k units. If k is positive, shift right by k units. So we'll call it as a delay. If k is negative, shift left by k units. We'll call it as advance. So we can have an example here. So this is bidirectional input signal. So this point, this arrow mark tells you that at 4, n is equal to 0. So if it is n equal to 0 now, n equal to minus 1, minus 2. Here it is 1, 2, 3. So the time period for this x of n is minus 2 to 3. Find x of n minus 2. So first one is to get the graphical representation of x of n. So here x-axis is your n, y-axis is your x of n. So minus 2 to plus 3. So for minus 2 it is 1, n equal to minus 1 is 2, n equal to 0, 1, 2 is 4, n equal to 3, the value is going to be minus 1. Here x of n minus 2, so the k value is going to be 2 because the standard form is x of n minus k. So your k is equal to 2, which is positive. So you are going to shift right by k units, that is 2 units. So we'll call it as delay. So the simple tip here is whatever the k value you have, you just simply add it with the starting time period of your input signal, right? So if it is 2 is added with minus 2, the value is going to be 0. So you are going to shift right for 2 units. So from minus 2 to minus 1 is first shift, minus 1 to 0 is going to be the second shift. So from 0 it will move, that is it will be shifting. So 1, 2, 4, 4, 4, 1 will be shifted to 0, 1, 2, 4, 4, 4, 1. So instead of minus 2 to 3, it is shifted to 0 to 5. So we will call it as a delay. So your x of n minus 2 is same 1, 2, 4, 4, 1. But here since you don't have any arrow mark, it tells you that the first value is n equal to 0. Next is for the same input signal, we can find x of n plus 1. So first draw the x of n graphical representation. Here the k value is minus 1 because the standard form with x of n minus k. Right, so k is minus 1 because minus of minus 1 will be plus 1. N is negative, so shift left by k units, that is 1 unit. So we'll say it is an advance because minus 1 will be added with your minus 2. So it becomes minus 3. So you are going to shift 1 left. So from minus 2 it becomes shifted to minus 3. So from minus 3 it's going to be 1, 2, 2, 1, 2, 4, 4, 4, 1. So n of n plus 1 is 1, 2, 4, 4, 4, 1. So where this n equal to 0 is going to be the second n here, right? So for second 4, the value of n is equal to 0 here. So this is your x of n plus 1. Now let us see the time shifting in CT signals here. So it is represented by y of t equal to x of t minus k. So irrespective of your signal, whether it is DT or CT, the rule stands. So k is positive means shift right by k units, we call it as a delay. If k is negative, shift left by k units, we'll call it as an advance. So find x of t for the given input signal x of t minus 2 for the given input signal x of t. So here k equal to 2, so we are going to shift right by 2 units. So add this 2 with your minus 1. So 2 minus 1 it will become plus 1. So minus 1 to 0 is first shift, 0 to 1 is going to be second shift. So I'll be shifting the entire signal to 1. Similarly, find x of t plus 1 for the given input signal x of t. Here k value is minus 1. So shift left by 1 unit. So from -1 to -2, because -1 will becomes -2. So I'll be shifting the entire signal left by 1 unit. Thank you students. So you can visit my blogspot and you can subscribe my YouTube channel for further updates. Thank you.